Would you believe me if I told you that an organism smaller than your eyelash is being used to discover new treatments for cancer? Caenorhabditis elegans, or C. elegans, is a tiny, simple worm that we study to learn more about larger, complex organisms like humans. You might be thinking, no way, these creatures don't look like us. But we're alike in invisible ways. We have 60% common genes. However, our similar genes operate differently. For example, gene RAS can be found in C. elegans, where it controls organ formation, while in humans it controls cell divisions. Imagine RAS as a gardener looking after a blueberry field. If many gardeners are working in the same field, they will produce an abundance of blueberries. But a field without gardeners remains empty. In C. elegans, RAS controls the formation of one reproductive organ. If RAS is activated more than usual, the excessive RAS proteins lead to the formation of many abnormal blueberries all over the worm. However, in humans, genetic modifications in RAS result in fast, uncontrolled growth of cells, which could form a mass called tumor. In fact, RAS activation is reported in a type of leukemia called AML, a cancer that happens when certain blood cells multiply quickly and uncontrollably. Current chemotherapy for AML hasn't changed for decades, and patients are developing resistance to it. My PhD is about the discovery of new drugs that could cure AML. I use a molecule called Imiqualines, created by our chemists, and as a biologist, I study its anti-cancer effect by testing it on cancer cells and C. elegans. Moreover, since C. elegans is an invertebrate that can't feel pain, so it allows us to reduce animal testing and suffering. After I treated the worms with Imiqualines, I found that the blueberry shapes disappeared. So this molecule is inhibiting RAS and controlling the abnormal organ formation in C. elegans. Then I wondered, could Imiqualines also inhibit RAS activation responsible for cancer in humans? Indeed, I discovered that Imiqualines put a stop to the rapid multiplication of cancer cells from AML patients and lowered the activity of proteins influenced by RAS. I want you to think about all the other health problems related to genetic changes that we have in common with C. elegans. And imagine how, one day, this tiny yet remarkable worm could be part of the solution to curing those diseases. Now, do you believe me when I say that I'm using a creature smaller than an eyelash to discover new treatments for cancer?